So good morning, everyone, or afternoon, wherever you are located in the world. My name is Alfonso Rivera, and I am the chairman of the Transboundary Aquifers Commission. And for the last 2 decades, I was the Chief Hydrogeologist of the Geological Survey of Canada. I am very excited today, and I appreciate this invitation by John and Amanda and Julia and Everton, the groundwater team, the Groundwater Project team, because that provides me a good opportunity to tell you about our country in Canada, particularly the groundwater resources of Canada. So I will provide some perspectives on the Canadian hydrogeology over the next 25, 27 minutes or so. To do that, I thought about using my book. You see here on the left-hand side, Canada's Groundwater Resources, which I wrote, edited, and published in 2014. But I won't present the book. Rather, I will use images and data and figures from the book to develop my talk, which is divided into 5 themes that I chose myself. So you have on the right-hand side, well, we'll begin with the country, telling you a little bit of tourism, so to understand what Canada is about with its geography, landforms, some water issues we have. I'll move on to the second theme, providing and describing the aquifers of the country, beginning with the hydrogeological regions. And then I will stop a little and describe the groundwater resources of Canada using water balances and the use of groundwater in our country. I will spend a little bit more time to something that I personally believe is becoming like a shift in the way we study systems, particularly in large countries such as Canada, and that is the groundwater flow systems. So I will provide various scale from continental scale to local scale. The last theme I will cover before summary, I thought it was interesting to provide a look, an overview on how does a multi-jurisdictional country, a federation like Canada, how do we do with the governance to the sustainable groundwater management of our resources? Right, so here we go. Let me then present you the country, Canada. Well, Canada is a very large country. It's nearly 10 million square kilometers. Actually, it places us as the second largest country in the world, right after Russia. 9.1 million square kilometers of our country is landmass, and the rest, approximately 800,000 square kilometers, are water bodies, rivers, lakes, groundwater, you name it. However, about a third of the landmass that you can see here from this line, black line here to the north, is the permafrost. So this is not much happening there. And then we are a country with a very unique geology and very distinctive geology forming aquifers. Anything from rocks that were formed in the last glaciation 10,000 years ago, combined with very, very old rocks, up to 2.5 billion years old, joining together forming aquifers. So in a nutshell, that's what it is. Now, we also have many, many distinctive landforms of physiographic regions in the country. We are all the way from the Pacific Ocean to the Arctic Ocean to the Atlantic Ocean. As you can see here on the north in magenta, in rather purple, you see the Arctic lands. Most of them are islands that go all the way up to the Pole North, almost. And then we have a very big chunk here, like in green pale, which is the Canadian Shield. The Canadian Shield is the rocks that are very consolidated, very old rocks, not really having a lot of aquifers in there. In between, we find the Hudson Bay lowlands here, indicated with yellow, more or less. And this is a very interesting part because most of the area here is composed of carbonate rocks, forming lots and lots of karst aquifers. I thought not many people live there, but this is very good for ecosystems. If we go to the west, we have the Cordillera, a very, very large part here. And that's mostly where the mountains are located, the Columbia Mountains, the Rocky Mountains, the Coast Mountains. There's many aquifers, but very small, rather. Then we have the interior plains, which is essentially composed of sedimentary basin, and you have many aquifers, and the largest of the aquifers in Canada are located in this part. Going all the way to the east, we have a smaller physiographic regions, but very important ones, such as the St. Lawrence lowlands. It begin in southern Ontario, go all the way to Quebec, where most of the people live, actually. And then we have the Appalachian region, smaller provinces with also important aquifers, although not very large. Now, let me make a cross-section from the Pacific to the Atlantic here, and you will see that, in fact, these landforms are striking. I mean, you have 4 of them here, the Western Cordillera to the west, anything from 0 elevation to 4,000 meters in the Coast Mountains, the Rocky Mountains. Then you have the interior plains, essentially where the prairie provinces are located. Alberta, Saskatchewan, and Manitoba. This is flat land, rather. And then to the right-hand side, to the east, going to the Atlantic Ocean, we have the Great Lakes, St. Lawrence lowlands, somehow sandwiched between the Canadian Shield, which I mentioned already, and the Appalachians, coming all the way from the States. So there you have it. This is a very good view of how the country looks like. Water, that's the subject today. Well, it's everywhere. I don't show everything, otherwise it will be crowded. But we have millions of lakes, thousands of rivers, all sizes. Now, that doesn't mean that that because it's a lot of water that we have an abundance. You will understand soon that, in fact, I'm showing only the rivers now, draining to the 3 oceans, Pacific, Arctic, and Atlantic. And you can see on the right-hand side at the top, the flow scale of cubic meters per second. For instance, you see the Mackenzie River here from the prairies all the way up to the Arctic. That's the largest flow that we have. Or the St. Lawrence River from the Great Lakes all the way to the Atlantic, or the Columbia River going to the Pacific. So we drain water to 3 oceans, actually a 4th. If you look at this piece here, that's the green level here on the border with the United States. That's the Middle River watershed. Even though it's small, well, that water drains to the south, eventually draining the Mississippi River in the USA, and it goes all the way to the Gulf of Mexico. So those are the rivers. So you might have an idea that that's a lot of water, but think about this: 60% of the runoff of all these rivers actually drains to the north, whereas the population, 85% of population, lives in the south. So we are not located where most of the water runs to. Okay, well, that doesn't mean that we don't have water issues to solve for in Canada. Actually, we have many. Particularly, we have stresses, population growth, very strong climate variability, and most recently, climate change effects on water resources. How about uses? Well, there are many uses, beginning with our own water footprint, and then the largest uses, agricultural energy. But we have domestic, industry, environment, and of course, virtual water. Hazards. We have hazards as well in Canada. If you follow the news, you have probably read recently, we have fires, we have droughts to the west, and we have floods. And how about water security, which translates as water scarcity? You might think that we don't have water scarcity, which we might not. However, water scarcity is not constrained within one country. It goes beyond. And you know what I mean. Right, let me go into the second theme now, the aquifers. What we did when I was working at the Geological Survey of Canada, and this map comes from my book, from Sharp et al., we divided the country in 9 hydrogeological regions, actually combining climate, geology, with, as you can see here on the right-hand side, moisture regions of Canada. This is interesting because, as you can see, less than half of the country to the east is where most of the humidity is located, most of the rain. As you go to the west and the central Canada and north Canada, actually it's dry, very dry some places, and a little bit on the Cordillera as well. So combining that with the geology, we came up with the permafrost, which I already mentioned before, the Percambian Shield hydrogeological region. Yes, there might be groundwater, but not many aquifers or important aquifers. And then we have the plains. The plains here is very large, and that's where most of the aquifers are located, both bedrock and unconsolidated material. The Cordillera in green, actually British Columbia and the Yukon, is also very humid, but there are also small aquifers only in valleys and other areas. As we move on to the center, I mentioned the Hudson Bay lowlands, a very important region, karstic aquifers, most of them. And then the last regions towards the center, South Lawrence, the lowlands here, green, orange, sorry, and then the St. Lawrence lowlands and Ontario lowlands, I'm sorry, where people live. Then we have at the very end on the east, the smaller provinces, the Appalachians here with aquifers are also formed, and the maritime basins with many people depend on groundwater. So that'll give you an idea of the hydrogeological regions. Now let me tell you about the aquifers. Well, this is a map of the principal aquifers and aquifer systems of Canada at the scale of 120 million. You can imagine that at that scale, it is virtually impossible to show every aquifer found in Canada. A total of 57 principal aquifers are shown on this map. 41 of them are located in bedrock, basically three types: clastic rocks, sandstone dominated mainly, carbonate rocks, limestone dominated, and a mixture of interbedded lithologies with shale and others. And then there are only in this map up to 16 unconsolidated sand and gravel aquifers. Although they are not very large, they are very important, and these are remnants of the last glaciation. The rivers, glacial rivers, fill in with sand and gravel mostly. The wide area here, very large, represents both the permafrost as well as the Canadian Shield, where you don't find many aquifers, or they are not important. I also like to say, before I leave this map, that we also have 10 transboundary aquifers shared within Canada and the USA. They are indicated here in dashed lines. The sizes of the aquifers are the largest from 125,000 kilometers to 50,000 kilometers, mostly here. This is the Basketball Formation and the Western Sedimentary Basin. And then very small aquifers, but important ones, such as the Sandy Lands here in number 49, which is a small, only a few square kilometers, but important because it's transboundary. Now, the last thing I say is that this map is still not officially published yet. It's still in review. Right. Okay, so let me go into the third team today, the groundwater resources. So we talk about the regions, we talk about the aquifers. Now let me tell you about the water itself. Right, these two figures are also from my book, and I like to show this using balances. So we receive an average 5,500 cubic kilometers of precipitation every year in all forms, rain, snow, ice. 40% of that, it goes up in the atmosphere as evapotranspiration with 2,200 cubic kilometers. And 53% drains to the three oceans, as I already mentioned before. 7% of precipitation infiltrates into the ground and recharges the aquifers of Canada with approximately 385 cubic kilometers every year. If you look at these numbers again, but you will see that, in fact, it's strange how evapotranspiration is smaller than runoff, which is a little bit contrary to most countries. Just look at North America, Mexico, and the USA compared to Canada. It is the contrary. In those two countries, runoff is smaller and evapotranspiration is higher. And that reflects actually the climatic conditions and the geology of our country. To the right-hand side of the bottom, you see the use of groundwater. Of water in total, we use approximately 45 cubic kilometers every year. 44 of them is from surface water. And as you can see, surface water is mostly used by industry, 70% domestic and 11% agriculture. When you look at groundwater, even though it's only 1 cubic kilometer, well, domestic and agriculture are very heavy users of groundwater, and industry only 14%. So that gives you an idea of groundwater resources in a country. Now, if we look at it a little bit closer by jurisdiction, by provinces, you look at the cylinder here at the top, a light blue indicated the use of surface water, dark blue at the bottom indicated the use of groundwater. And so if you look at the provinces and territories, you will see that it goes anywhere from 21% of groundwater use in the province of Alberta up to 100% groundwater use in the province of Prince Edward Island, which is an island. And this is the smallest of the provinces, but is the one that uses the most groundwater. Just for fun, and let me show you to the north, even though there are many people. Well, in the Yukon, for instance, 65% of the population use groundwater. In the prairie provinces, it is Saskatchewan, the largest user of groundwater, with 39%. In terms of time, we went from about 20% of the population relying on groundwater back in the 70s, and it went all the way up to 30% at the turn of the century. Now, don't forget, an interesting fact, it is a big country, yes, but a small population, only 38 million inhabitants. I like to say for fun to my friends in Brazil, the population of Canada is about the same population of only one state in Brazil, Sao Paulo. Anyway, the other thing that is of interest is that the groundwater resources, actually all the water resources in Canada, are not managed by Canada, by the federal government. They are managed individually by each jurisdiction. Last thing on this subject, when you go out of the urban zones, out of the big cities where you have infrastructure, etc., and you go into smaller municipalities, which I dotted here, I map here in dots, in black dots that you can see all over in the prairies, in the Canadian and the eastern part of the country, I'm sorry. Those are municipalities relying 100% on groundwater. In other words, as you move out of the centers, there's no infrastructure, even though there are rivers, people drill wells and they rely on groundwater 100%. A very interesting fact. All right, 14, the groundwater flow systems. Now we all know that the groundwater dynamics is a matter of scales, a matter of time and space scale. This is known. So what I try to do is show schematically, at least, the map in 2 dimensions, horizontal, with at least 3 distinctive groundwater flow systems in Canada. This is the continental scale. You see the large arrows here, intermediate and local, indicating flow systems. Basically, what I'm showing is that from the western part of Canada to the northeast and east of Canada, you have mostly regional scale groundwater flow systems, a little bit from the south in transboundary aquifers from the USA to the north. Many others are located in the Hudson Bay, in the St. Lawrence lowlands, Great Lakes Basin, intermediate flow systems, and also to the west in the boundary with the USA. Of course, I cannot plot local scale, but I can tell you there are so many here, and the Rockies, in the Appalachian, eastern part of the country. They are very small, but they are important sometimes. I'll show you this map. It's a very interesting. This is modeling at continental scale done by Shen et al. In 2019. It's interesting to notice at this scale that the groundwater head is mostly from 2,400 to 0 at sea level, and mostly on the western side of it. If you look at 2 cross sections, AA prime and BB prime, you see the Rocky Mountains behavior and the Great Lakes Basin hydraulics. In the Rocky Mountains, water infiltrates on top of the mountains, on the slopes, by melting the glaciers and whatnot. And then it infiltrates, and it will go, depending on the geology, very quick in following the next valley or rivers that would eventually go into the Pacific Ocean or the Atlantic Ocean. Some part of the water infiltrates deeper, depending on the geology. It might take longer residence time before it discharges into the atmosphere. This is modeling, and I'll show you later, the same situation that we experimented and observed by measuring GRACE observations from space. Now let me look at the groundwater head here in the Great Lakes Basin. It's not exactly the same behavior as in the Rockies. Yes, we do have differences in head, although mostly it's flat. But the groundwater that infiltrates into the ground does not necessarily go and feed, so to speak, the lakes. In this case, 3 lakes, Michigan, Huron, and Ontario. Instead of that, what groundwater does, it infiltrates, it feeds the rivers that feed the lake. So as you can imagine, then groundwater plays a very important role in the water balance of the whole basin. And this is a very unique thing in groundwater. two more examples that I show you here, a little bit more regional and local scales. On the left-hand side, we have the Mill River Transboundary Aquifer that we mapped together with our colleagues from the US. This is a transboundary aquifer shared between Montana and the US and Alberta in Canada. So recharge is done in the Sweetgrass Hills, approximately in the border here region, and then groundwater moves towards the northwest and toward the southeast. By using different methods, modeling and isotopes, we discovered up to 6 groundwater flow systems. So very recent groundwater, fresh recent groundwater, and then as you move north, 200,000 years old groundwater, all the way up to 1 million to 1.5 million years old warm water. So it takes very long, it's very slow to move up all 100 to 150 kilometers to the north, but also to the southeast here in Montana. On the right-hand side, this is not modeling, this is a signature from GRACE that you might know of. We tried to study the melting of the glaciers in the Rockies. And what we observed during 70 years using the GRACE signature is that the melting of the glacier is losing mass in the order of 3 cubic kilometers per year during that period of time. So what happens to that water? 78% drains to the west into the Pacific, rivers, and groundwater, and only 22% drains to the east, to the Hudson Bay and the Atlantic. Now, what is interesting here is that the groundwater that infiltrates, or the water from the glacier that infiltrates into the ground in the mountains, if it finds superficial aquifers, the response time is very quick, a year to 10 years or so before it reaches the next outlet, a river, a lake, and runs out to either to the west or to the east. But we also found that as groundwater infiltrates further into the mountain, depending on the geology, of course, it might take much, much longer, in the order of thousands of years, before it reaches an outlet and eventually leave the system. All right, the last example on groundwater flow system, now to the east of the country, the St. Lawrence River here, in a cross-section to the south of the area in the border with the United States, that's the Appalachian. We observed, our colleagues observed, the up to three distinct groundwater flow systems. The dark arrow here indicates groundwater that moves very quickly into the ground and eventually leaves the system on the slopes and the hills of the Appalachian. A second system, a little bit less and longer. It might take a little longer until it reaches the St. Lawrence platform. Eventually, in the dashed line that you see here, much deeper groundwater, infiltrates deeper groundwater, much longer. It will eventually find faults, like the Logan Fault in this case, or the Rivière Jacques Cartier Fault, and eventually will move up into the St. Lawrence. That takes much, much longer. So there you have it. Those are the groundwater flow systems in our country. Not complete, but it gives you an idea. My last theme before I summarize, I'd like to tell you about governance and sustaining groundwater management in Canada. So this is a challenge. I mean, Canada, as I say, is very large and it's also very complex in terms of jurisdiction and management. So we have a decentralized government, federal, that is, 10 provinces, 3 territories, drain into 3 oceans. It's like 13 countries, actually. So water resources management is shared by these jurisdictions and is divided further into 4 levels of government that I don't have time to describe. At the federal level, where I worked for 21 years, we noticed that there are up to 20 federal departments somehow involved in water management, mostly in transboundary issues, but also helping provide science and technology to water management. We learned over the years that cooperation will lead to knowledge, which in turn will help better management as data and information becomes available. And that eventually provides sustainability of the resource. Together, we call that governance. And at that time, the year 2000 or so to 2005, national workshops recognized that gaps in the groundwater knowledge might hinder good groundwater management and governance. So a few years later, in 2009, the Canadian Council of Academies proposed a common framework for aquifer classification, characterization, and groundwater flow systems to allow integration of data from local studies into broader regional national assessment. So they proposed these 5 goals for sustainable groundwater management that I show very quickly now. So protection of groundwater quality from contamination, protection of groundwater supplies from depletion, protection of ecosystem health, of course, achievement of economic and social well-being, and finally, the bottom line is to apply good governance practices. I won't have time to show everything. I just chose 2 very quickly. So protection of groundwater quality from contamination, what it means is that we have to protect drinking water quality and prevent impacts on groundwater from risky land use practices. Installing monitoring wells is very important for early detection of contaminants and remediate and restore once groundwater is contaminated. And the last I show is the application of good governance practices that we came up with the CCA through workshops, etc., is to apply best management practices for allocating groundwater. Decisions need to be made transparent and the public should participate. Not forget to include ecosystem needs. All right, so let me summarize what I've been saying over the last 20+ minutes. All right, so yeah, this is a country that is large, but this is very small population, only 38 million people. A continental-sized type of country such as ours, having 3 oceans, millions of lakes, thousands of rivers, many unique landscapes, very strong climate variability, and hundreds of aquifers. The annual use in our country of groundwater is 1 cubic kilometer, and the recharge is approximately 385 cubic kilometers. And 30% of the population rely on groundwater for domestic use, but it is much higher when you go in rural areas. Groundwater knowledge now is high. We have learned a lot over the last 20 years or so, but it's still incomplete. And we have challenges: multi-jurisdictional management, how to combine science and technology with groundwater management and governance. And we have very important groundwater scale issues of time and space that we haven't resolved yet. And to do that, we are using Earth observation as a new tool to assess groundwater dynamics at very large scales. I will say that communication and education on water sciences is very high in Canada, and it's well known. Canadian universities with hydrogeology degrees are among the best in the world. Now, however, cooperation between physical sciences, hydrogeology, and social sciences is rather poor and is necessary. It should increase. And that's why I believe that the Groundwater Project is ideal to do that, and it's doing it already. I didn't mention this, it will take another talk, but nowadays Canada as a whole is trying to put together a Canadian water agency by the federal government, maybe another talk. So merci beaucoup, thank you so much. And before I leave you, I would like to say that my book is available, where I took many of the figures today. You can either buy it, hard copy for 150 Canadian dollars, or you can have access for free. The whole book, 803 pages, a PDF in GeoScan is a federal entity through this link, or you can also access it per chapter. There are 16 chapters on this link. Obviously, I don't pretend that you will copy this link. So if you are interested, send me a note and I'll send you the links. Again, thank you so much indeed.